This is the NEET 2016 question in current electricity. It says the charge flowing through a resistance R varies with time as AT minus BT square, where A and B are the positive constants. What is the total current produced in a given time interval? So first thing, when charge is given for you, Q equal to AT minus BT square, to calculate the heat, first I need the current, where current is defined as rate of flow of charge dq by dt. So I shall integrate this equation. I shall differentiate this equation. So A differentiation of t with respect to dt, that means dt by dt, that is equal to 1 actually, minus B differentiation of t square. We are having a formula differentiation of x power n equal to n into x power n minus 1. So differentiation of t square is 2 into t power t minus 1, that is 2t. So differentiation of t square is actually 2t. So the current that what we have got is A dt by dt is 1 actually, minus 2b into t. As he wants the total current, I can say for total current for I maximum, dq by dt, that is I, has to be equal to 0. That means A minus 2b into t equal to 0. That implies t equal to A by 2b. It means to say after a time from 0 to A by 2b, current becomes maximum, and hence the heat through it also becomes maximum. That's the first thing that we need to understand. Once after knowing that basic aspect about current, I can go out and talk about heat generated. Heat produced is H equal to integral of I square R dt, where I know I. So let us substitute that value. I means, as I have calculated, A minus 2b into t whole square R dt, where the time limits are from 0 to, as I have calculated, A by 2b for getting the total heat. So let us simplify. Integral of, I will apply the limits at the final stage. This is A minus b whole square, that is A square, plus b square means 2bt whole square, 4b square t square, minus 2ab. 2ab is again 2bt, that means 2a and 2, that is 4ab and t, for all of that R dt, where limits are from 0 to A by 2b. Let's integrate this. I have a formula. I want you to remind integral of x power n dx equal to x power n plus 1 by n plus 1. So integral of t square dt is t power of 2 plus 1 by 2 plus 1, that is t cube by 3. Similarly, integral of t, that is t power 1 dx dt is t power of 1 plus 1 by 1 plus 1, that is t square by 2. Let us substitute all these values and calculate the value of the heat generated in the process, right? Yeah, it implies heat generated equal to, I'll substitute here, integral of a square r dt, that is a square r integral of dt, plus I am writing the second term now, 4b square is constant, r is constant, integral of t square dt. I am integrating each term separately for the convenience, minus 4ab integral of t dt. Let us calculate this. A square r integral of differentiation of t is t itself, 4b square r integral of t square dt, as I have calculated, t cube by 3 minus 4ab integral of t dt is t square by 2. Every time this t is varying from 0 to, as I have calculated limits, a by 2b, 0 to a by 2b, because after a by 2b it becomes maximum, 0 to a by 2b. Let us simplify this and see what our answer is. That implies heat generated is a square r, in the place of t, first I have to write upper limit, that's how we have to solve integration, minus lower limit. That's the first term. Look at the second term. 4b square r by 3 also can be taken out. In the place of t cube, a by tb whole cube minus 0 cube. That's the second term. Look at the third term. 4ab, these two also can be written outside. In the place of t square, a by 2b whole square minus 0 square. That's what our answer is. Let us simplify this. H equal to a square r of a by 2b. Second term, 4b square r by 3 a cube by 8b cube. Third term, 4ab by 2 a square by 4b square. Let us further simplify this. H equal to a square r into, this is the first term, right? So it becomes a cube by 2b of r. Look at the second term. This 4 is of 2 times. This b square will cancel out of b cube and only one b is remaining. So what's the second term is? A cube by 3 into 2, 6b of r. Look at the third term. This 4 and 4 will cancel. This b and 1b will cancel in b square. A and a square is a cube by 2b is remaining, right? But I have forgotten something. This third term is minus, so I have to correct it, right? This third term is minus. As the third term is minus, yeah, give me a second, my pen is not responding. Yes, this third term is minus. This third term is minus. This third term is minus. So let us simplify this and identify what is our answer is, right? That implies H equal to a square by 2b of r plus a cube by 6b of r minus a cube by 2b. For all of them, 6b is LCM. Sorry, this is also a cube. Yeah. So as it is 2b, it has to multiply with 3. 3 a cube r. As it is 6b, I have to write as it is a cube r. As it is 2b, again I have to multiply with 3. 3a cube r. Right? R is there everywhere, even in the third term also. For every term, 4ab, yeah, look at this equation. R is there everywhere. So here also I have forgotten writing R. For the third term also there is R. There is R. Yeah. So what happens? 3a cube r minus 3a cube r will cancel. So what is the heat remaining is a cube r by 6b. That's option number 4. So I have missed some calculations here and there while I am doing. So you have to be careful that you shall not miss any of the terms when you are doing a lengthy calculation. That is important. Therefore, I won't get a wrong answer, right? That's how we solve the problem. Thank you for watching. Relook at the problem. resolve it on your own paper. Don't look at the solution and say you got it. You do it yourself and see, make sure that you get it right. Thank you for watching.